Welcome back to Database Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Before we dive in, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're wrapping up our chapter on database architecture with a comprehensive summary. This is an exciting moment as we tie everything together.
Absolutely, Victor. And to kick things off, I have a quiz question for our listeners. Here it is. In a large e-commerce platform that handles millions of transactions daily, which database architecture would be most suitable? Single-tier, two-tier, or three-tier? Think about it, and we'll reveal the answer at the end of the episode.
Oh, that's a great question, Sheila. It really makes you think about the scalability and complexity of different architectures. I'm sure our listeners will have some interesting thoughts on this. Let's break it down a bit without giving away the answer. What factors do you think they should consider?
Well, they should definitely think about the volume of transactions, the need for data security, and the potential for future growth. But let's not give too much away. Before we dive deeper, could you quickly refresh our listeners' memory on the key terms we've covered in this chapter?
Certainly. We've discussed several types of database architectures. Single-tier architecture is where everything, data storage, processing, and user interface, is on one system. Two-tier separates the database from the application. Three-tier adds a middle layer for business logic. N-tier expands on this with multiple layers. And finally, the client-server model distributes processing between clients and a central server.
Thanks, Victor. Now, let's start our summary. I remember we talked about how database architectures have evolved over time. Could you give us a brief historical perspective?
Of course, database architectures have come a long way. In the early days, we had mainframe systems that were essentially single-tier. As computing became more distributed, we moved to client-server models, which are two-tier. The need for more scalable and maintainable systems led to the development of three-tier and N-tier architectures. Today, we're seeing even more distributed systems with cloud and edge computing.
That's fascinating. It's like watching the evolution of buildings, from simple one-room structures to complex skyscrapers. Speaking of which, could you give us an analogy to help visualize these different architectures?
Great idea. Think of database architectures like building structures. A single-tier architecture is like a studio apartment. Everything is in one space. A two-tier is like a house with separate living and storage areas. Three-tier is more like an office building with distinct floors for different functions. And an N-tier architecture? That's like a sprawling campus with multiple interconnected buildings, each serving a specific purpose.
That's a helpful analogy, Victor. Now, I understand that each architecture has its pros and cons. Could you summarize these for our listeners?
Absolutely. Single-tier is simple but lacks scalability and security. Two-tier improves on this, but can still struggle with large numbers of users. Three-tier and N-tier offer better scalability, security, and maintainability, but they're more complex to set up and manage. The client-server model can be efficient, but may put a heavy load on the server.
I see. So, it's all about finding the right balance for your specific needs. Are there any common misunderstandings about these architectures that our listeners should be aware of?
One common misconception is that more tiers always mean better performance. In reality, the best architecture depends on the specific requirements of your application. Another is that client-server and two-tier are the same thing. While they're similar, client-server is a broader concept that can apply to various architectures.
That's really important to clarify. Now, let's talk about real-world applications. Can you give some examples of where we might see these different architectures in action?
Sure. A single-tier architecture might be used in a small business with a local database. Two-tier is common in desktop applications that connect to a database server. Three-tier is widely used in web applications, where you have a web server, application server, and database server. N-tier architectures are often seen in large enterprise systems or complex web services like social media platforms.
That's really helpful, Victor. As we wrap up this chapter, what do you see as the future trends in database architecture?
Great question. We're seeing a move towards more distributed systems, with technologies like edge computing and serverless databases gaining traction. There's also a trend towards hybrid architectures that combine elements of different models to meet specific needs. And of course, cloud-native database architectures are becoming increasingly important.
Fascinating. It seems like the field is constantly evolving. Before we conclude, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, for a large e-commerce platform handling millions of transactions, a 3-tier or N-tier architecture would typically be most suitable. This allows for better scalability, security, and separation of concerns, which are crucial for handling high volumes of sensitive transaction data.
Thanks, Victor. To summarize our key points, we've covered the evolution of database architectures from single-tier to N-tier, discussed their pros and cons, clarified some common misconceptions, and looked at real-world applications. We've seen how choosing the right architecture is crucial for system performance, scalability, and maintainability.
Excellent summary, Sheila. And remember, listeners, understanding these architectures is key to designing effective database systems. Whether you're working on a small project or a large enterprise system, these concepts will serve you well.
Absolutely. And that brings us to the end of our database architecture chapter. We hope you've enjoyed this journey as much as we have. If you found this helpful, please visit crashcasts.com to find more resources. Don't forget to join our Discord community, where you can discuss these concepts with fellow database enthusiasts. And if you'd like to support us, consider becoming a patron on Patreon. Your support helps us create more great content like this.
Thanks for listening, everyone. Until next time, keep exploring the fascinating world of databases.